Okay, this time we're going to talk about translating our words, English words, into math expressions and equations. Okay, a phrase translates to an expression. A phrase is not a complete sentence, right? Just like these are expressions as opposed to an equation. So, in sentences, we can translate into equations. Okay, so write each phrase as an algebraic expression, and it tells us to use x as the variable. Technically, we can use anything we want. Pay attention if it tells you to use a particular variable, it's going to count it wrong if you use something else. But when we're trying to solve a word problem, it's nice to use a variable that describes what you're talking about. Remember when we talked about the systolic blood pressure and the A stood for age? So things like that. Or C stood for class limit. Okay, so a number plus 2. That one's, I hope, pretty self-explanatory. To write it out, we'd have a number, and it tells us to use x as the variable. So whenever it just says a number, that's our variable. We don't know what number. So x plus 2, right? The sum of 8 and a number. There are 4 math terms that we need to know. Sum, difference, product, and quotient. Sum is the answer to an adding problem. Difference is the answer to a subtraction problem. Product, the answer to a multiplication problem. And quotient, the answer to a division problem. Okay, so whenever we have any of these words, these 4 specific math terms in our expressions or equations, okay, it means I'm going to put this sign, I'm going to, at the next and. Okay, and maybe these are very simple, but when they get more complicated and there's a lot going on, this is going to be important. So when I have that word, I'm going to look for the and that tells me that's where a plus sign is going to go. If it said the product, I would look for the and that's where my minus is going to go. Okay, so the sum of 8 and a number means 8 plus x. 5 more than a number. Now, more than means adding. And so remember, addition is commutative. So it really doesn't matter if I write this like this or this simply because it's adding. But technically, the wording here is for this one. So I want to be careful about that, because if this was a minus, 5 minus x and x minus 5 is not the same. So I really want to match my order in my algebraic expression with what the words are saying. So this is saying, oh, I've got 5 more than a number. It means you're going to start with a number and you're going to add 5 to it. 5 more than a number. Okay. A number increased by 6. A number increased by 6. Okay. 9 less than a number. Here's where we'd get in trouble if we weren't being careful. 9 less than a number is, hey, that means I've got a number and 9 less than. Now this one I cannot mix up the order. It has to be x minus 9. A number subtracted from 3, right? So that's this. A number that has been subtracted from 3, indicating you start with 3 and you're going to subtract a number from it. A number decreased by 4. So this is a number, and if I want to decrease it by 4, now 10 minus a number, that one's pretty straightforward. But be careful about these orders. Okay. Okay. 8 times a number. You can put a dot between there, or you can put it in parentheses if you want, but this is 8 times a number. The product, so a multiplication goes right there. 12 and a number. Double a number. What does double mean? Right, multiply by 2. Triple, multiply by 3, right? The quotient, there's one of those words, so I know a division sign goes right there. -6 divided by a number. Or you could write it like this, either way. Now this is a number divided by 10. Right? Or this, both of those are perfectly acceptable. Okay, 15 subtracted from 4 times a number. So here's 4 times a number, and I want to subtract 15 from 4 times a number. Okay, so what's the difference? How would I know that this isn't 15 subtracted from 4 and then times a number? If it was like this, I'd need a comma right there. Okay. Okay. Now we want to translate these sentences into equations. If 5 times a number is added to 11, the result is 26. Find the number. Okay, so 5 times a number is added to 11. Technically, that's like this. Now, because it's adding, it doesn't matter which order you put it in, but the words are saying this. 5 times a number is being added to this 11. The result is, your is always your equal sign. Is 26. Now let's find the number. Oh, we've got an equation. We can solve it. On expressions, we couldn't solve any of those expressions and tell you what the variable represented, right? But with an equation, we can solve it. Okay, so I got to subtract 11 first because there's no other steps, no fractions, no parentheses, no simplifying. So undo whatever's being added or subtracted to the variable. 0 plus 5x is 5x. 26 minus 11 is 15. Undo what's being multiplied to the variable. So divide both sides by 5. X equals 3. And that's our number that we were looking for. Oh, tells us to let X represent the unknown number. We did that anyhow, but okay. Now here's the steps for solving application problems. First of all, read the problem as many times until you understand what it's about. At least once before you start trying to work it, but you might have to read it 2 or 3 times. It's the English that's the problem, right? Read it carefully a second time. Okay, as you read, make a sketch or write word phrases that identify the known or unknown parts of the problem. If there's one unknown quantity, assign a variable to represent it. Write down what your variable represents. Okay? So they're going to do things like say X equals the age, Y equals the class limit. Okay, I'm going to do things like A is the age, so I don't necessarily have to identify it so much. If there's more than one unknown quantity, assign a variable to represent the thing you know the least about. Then write an expression using the same variable to show the relationship of the other unknowns. That may not make sense here, but when we look at an example, maybe it will. Write an equation, solve it, state your answer, and check. Okay. So Heather put some money aside in an envelope for small household expenses. Yesterday she took out $20 for groceries. Today a friend paid back a loan and Heather put the $34 in the envelope. Now she has $43 in the envelope. How much was in the envelope at the start? Okay, so really I just have one thing I don't know, and so I'm just going to use X, right? So Heather put some money aside in an envelope for small household expenses. So she had some amount of money in the envelope. Yesterday she took out $20. She took out $20. Today a friend paid back a loan and Heather put the $34 in the envelope. Now she has $43 in the envelope. In other words, all this equals to $43. That is what is in the envelope now. And that's my equation. Okay, got some things I can simplify. So signs are different means minus. 34 minus 20 is 14. Keep the sign in front of the bigger one. Okay, undo what's being added or subtracted. So let's subtract 14 from both sides. So x plus 0 is x. 43 minus 14 is, what's that, 29? So she has $29 in the envelope. Michael has completed 5 less than 3 times as many lab experiments as David. If Michael has completed 13 experiments, how many experiments has David completed? Okay, so we know that Michael has completed 13 experiments, right? I also know that Michael has completed 5 less than 3 times as many as David, right? So 5 less than 3 times as many as David. Okay, does that make sense? So since these are both equal to m, then I know that 3x minus 5 equals 13, because they're the same thing. Okay, now solve the equation, add 5 to both sides. So 3x equals 18. Divide by 3. X equals 6. And what is x? Oh, x must be David. I should have used a D, right? Got caught up in my own thing. Yeah, I used a D. So now I gotta say David has completed 6 experiments. Complete. If I'd have used a D, I could have just said D equals 6. Last month, Sheila worked 72 hours more than Russell. Together, they worked a total of 232 hours. Now, here's what those instructions were saying. If you've got 2 things, the one I know less about is Russell. So I'm going to make this Russell. And Sheila worked 72 more than Russell. So this is really Sheila over here. Russell plus 72. Together, they worked a total. That means I'm going to add these things. So R plus 72, that's Russell plus Sheila. They worked 232 hours. There's my equation. So I've got some terms I can combine. 2R plus 72 equals 232. Undo whatever's being added or subtracted. 2R plus 0 is 2R. So what's that, 160? Undo what's being multiplied. Divide both sides by 2. So we have R equals 80. Now, because I used R, I don't have to explain Russell. right? But don't forget it says find the number of hours each person worked. Now I need Sheila's, but this is Sheila. Sheila was 72 more than Russell. So Sheila is 80 plus 72, or Sheila is 152 hours. Okay. The length of a rectangle is 2 centimeters more than the width. The perimeter is 68 centimeters. Find the length and width. If anytime I have a shape or something that I can draw in, I'm going to do that, right? The length of a rectangle, so the length is 2 centimeters more than the width. So it's the width plus 2. I don't know anything about the width, right? So this is what I knew the least about. The length was W plus 2. The perimeter, what does the perimeter mean? That's right, all the way around. So we add up all the way around. That means we have W plus W plus 2 plus W plus W plus 2, and that must be 68. The perimeter is 68. So here's my equation. I got some simplifying to do. There's 4 W's, and then there's a couple of constants I can add. Plus 4 equals 68. Undo what's being added or subtracted to your variable first, so that numeral is gone. 4W plus 0 is 4W. 68 minus 4 is 64. Undo what's being multiplied or divided by your variable. So W is 16. Now, once again, since I didn't use x's or anything, I know that's the width. So I don't have to go back and explain it. I can just say W equals 16 centimeters. And then the length is W plus 2. So 16 plus 2, 18 centimeters. Okay. Whoops. Yep, that does it for this section. Let me know if you need anything. See you next time.